Hello friends, welcome to Thorough Education on the digital class platform. Friends, in the earlier video we have seen exercise number 1.1, 1.2. Now we are going to see the real numbers and their decimal expansions. Real numbers, what are these? Friends, here we will clear what are real numbers. So here we can say terminating decimal. What is terminating? When the remainder becomes 0. When we divide one number by the other, then the remainder becomes 0. After some steps of division, it is a terminating decimal. When remainder becomes 0, it is a terminating decimal. Look at here. 15 divided by 4. If we do it, then first 3.75. 5, last 5 is the end of the division. So this decimal is terminating decimal. Here second thing, non-terminating decimal. Non-terminating, that means which does not stop at all. This decimal terminating stops, but non-terminating does not stop. It remains continuous for longer and longer, measure and number of steps. When the remainder does not become 0 after infinitely many steps of division, then it is a non-terminating decimal. If we do division continuously for many steps, infinitely many steps, but the remainder does not become 0, then it is non-terminating decimal. Look, 47 divided by 3. Here it is 15.66666666. 6 is continue, no end at all. So this is non-terminating. Clear friends? Terminating decimal and non-terminating decimal. It must be clear. Next, non-terminating recurring, that is repeating decimal. The numbers repeat. When we divide any number by other number and the remainder never becomes 0, but the same pattern is repeated, then it is non-terminating recurring decimal. You can see here in this 15.666, 6 is repeating. So it is non-terminating recurring decimal. Look, 343 divide by 13, right? So we get 26.384615. 384615, 384615, 384615. This is repeating. These decimals, these numbers that we can say, these digits repeat continuously. So we can show it by this 26.384615 bar. This is known as bar. What do we call it? Bar. The line above the digits is known as bar. Non-terminating, non-recurring decimal. Here it was terminating and recurring. Non-terminating and recurring. This one non-terminating but recurring. Here non-terminating and non-recurring decimal. When we divide any number by other number and the remainder never becomes 0, and the same pattern is not repeated. Here the same pattern 384615, 384615, this pattern repeats continuously. But in non-terminating, non-recurring decimal, pattern does not repeat at all. Then it is non-terminating, non-recurring decimal. Friends, remember the definitions which are given here. Here look, this one 1.01, 001, 0001, 00001. In this way, one zero increases after every one. One zero increases. So pattern does not repeat. Pi, right? 1.414233562309 in this way, number pattern does not repeat at all. Pattern does not repeat. So this is non-terminating, non-recurring decimals, and they are irrational numbers. Irrational numbers. What kind of numbers? Irrational numbers. Non-terminating, non-recurring decimals are irrational numbers. Terminating and recurring decimals are rational numbers. Right? But non-terminating, non-recurring decimals are irrational numbers. That we have to see here in the exercise. Look at the exercise 1.3. Here it is 1.3. Write the following decimals in the form of decimal form and say what kind decimal expansions each has. कौन से टाइप का डेसिमल एक्सपांशन है वो हमें कहना है. बहुत ही इजी है. 1.3 बहुत ही छोटा है, वो भी आप देख सकते हैं. लुक 36/100, right? So if there is 100 in the denomination, we can say 0.36, 0.36, right? It is terminating. It is terminating, not recurring or repeating, right? But it is terminating. It stops at 0.36. 1/11, 1/11. If we divide 1 by 11, we get this pattern, 0.09090909, right? So 0.09 bar. Bar means it is non-terminating. It does not stop, but it is recurring. Non-terminating recurring decimal. How is it? Non-terminating recurring decimal. Look at the third number. 4 integer 1/8. 4 integer 1/8. This equals to 33/8 because 4 8s are 32. 32 plus 1, 33. 33/8. This is improper fraction and this is mixed fraction. We have converted mixed fraction into improper fraction. If we divide 33 by 8, we get 4.125. 4.125. It is terminating. It is terminating. 3/13. 3/13. If we divide 3 by 13, we get 0.230769230769230769. The same pattern repeats. So we can say it 0.230769 bar. It is non-terminating and recurring decimal. Non-terminating recurring decimal. Right? Number 5. 2/11. 2/11. 0.18181818. Then it is 8 bar. 0.18 bar. It is non-terminating recurring. Again it does not terminate. It does not stop. It goes continuously for many numbers. So here we can write 0.18 bar. It is non-terminating recurring decimal. Look at number 6. 329/400. 329/400. So 0.8225. We get 0.8225 by dividing 329 by 400. Right? So it is terminating decimal. because it does not repeat, it does not go infinitely many numbers, so it is terminating, right? Now question number 2 is, you know that 1 upon 7 is equals to 0.142857. 142857. 1 upon 7 is 0.142857. Right? 2857 repeats. So, can you predict what the decimal expansion of 2 upon 7, 3 upon 7, 4 upon 7, 5 upon 7 and 6 upon 7 are without actually doing the long division? Right? Actually doing the long division. We should not do long division. But we have found out the solution. Look at here. We will not do actual division. Instead we multiply it. 1 upon 7. Right? 1 upon 7. So if we want to get 2 upon 7, then 2 into 1 upon 7. Right? So 1 upon 7 is 0.142857. So if we multiply both, we get 0.285714. Similarly, 3 upon 7 means 3 into 1 upon 7. So 1 upon 7 means this. If we multiply both, we get 4 to 0.428571. Similarly, 4 upon 7, 4 into 1 upon 7. That means 4 into 0.142857. So we will get 0.571428. Understood? Pattern. 5 upon 7. 5 into 1 upon 7. That is 5 into 0.142857. सेम नंबर से हम डिवीजन कर रहे हैं 7 से, but multiply by 5. So we will get this 6 upon 7. 6 into 1 upon 7 equals to 6 into 0.142857. Right? 857142. Now look at here. We have 142857. Right? 142857. 14 goes back. 2857. First 2 digit. Then what happens? 3, when we multiply with 3, then 4 2 will come up. 4 2. 42857. 1 goes at the back. When we multiply with 4, then 5 7 come up. Then 1428 goes back. Understood? Numbers are same. The digits are same in all these numbers. Right? So we have multiplied here with 2, 3, 4, 5, 6 and we got the answer like this. Okay friends, now let's move at question number 3. Question number 3 gives us express the following in the form of P upon Q. P upon Q, that means rational number where P and Q are integers and Q is not equals to 0. P upon Q. P upon Q means rational number. Now 0.6 is the first sum. If we want to convert the decimal into fraction, P upon Q, regular fraction, then what we do? 0.6 bar. Bar means 6 is repeating. Let x equals to 0.6 bar. Bar means repeating. 0.6666666. So we can write. Now after decimal there is one digit. After decimal there is one digit only which is repeating. One digit only which is repeating. So we have to multiply it with 10. With 10 only. So 10 into x, 10x, and if we multiply this by 10 we get 6.666666. Okay. Now subtracting 1 from 2, subtracting equation 1 from 2. So 2 will come up and 1 will go down. 10x equals to 6.666 and x equals to 0.666. If we subtract both 10 minus 1, that is 9x, and 6.666 minus 0.666, then it will be 6, right? So x equals to 6 upon 9. If we cut 3 2s are 6, 3 3s are 9, then 2 upon 3. Now friends, remember here in question number 2 says 0.47. Here 7 is bar. 7 has bar. Only 7 has bar, that is 0.47 bar. Right? The first digit does not repeat, the second digit repeats. So first of all, the number should multiply by 10 to get it like this. Look, let x equals to 0.47 bar, x equals to 0.4777 because 7 repeats, right? First I have multiplied by 10 to get the decimal point after 4. Decimal point after 4. 10x equals to 4.777. We must remember the numbers, the digits after decimal must be same while subtracting. मस्ट बी सेम वाइल सब्ट्रैक्टिंग. जब भी हम सब्ट्रैक्ट करते हैं, माइनस करते हैं, तब डेसिमल के पीछे वाले जो नंबर्स हैं वो सेम होना चाहिए. तो सेम नहीं है तो हम पहले इसको 10 से मल्टीप्लाई कर देंगे. तो 10x इक्वल्स टू 4.777 आ गया. अब इसको फिर से 100 से मल्टीप्लाई 10 से मल्टीप्लाई करेंगे. तो 10x को 10 से मल्टीप्लाई किया तो 100 हो गया. 100x इक्वल्स टू 47.777. Look at here, 777, 777. Okay friends, subtracting 1 from 2, we get here 90x because 100x minus 10x, that is 90x. 47.4777 minus 4.777, that is 43. So we have got x equals to 43 upon 90. Now we have 0.001. Here all the 3 digits repeat. Let x equals to 0.001. How many digits are repeating? 3 digits. So we have to multiply this by 1000x. 3 digits, 1, 2, 3. We must have 3 zeros on 1. So let x equals to 0.001, 001 and dot 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 dot. Here 1000x equals to 1.001. Subtracting this 1000x minus x, that is 999x. Sorry friends, here I have to write 999x because 1000 minus 1, 999, and here is 1. So here x equals to 1 upon 999. 19 I have forgotten to put in. So friend, consider 999 instead of 99. Okay. Sorry for that. Question number 4. Here express 0.99999 dot 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 in the form of P upon Q. सो फर्स्ट हमें p अपन q में कन्वर्ट करना है. Then are you surprised by your answer? With your teacher and classmates discuss why the answer makes sense. Up friends, first of all we will do it. How many digits repeat? 99999. That means we can say 0.999999 9 ही रिपीट होता है. नाउ 10 से मल्टीप्लाई करेंगे क्योंकि 1 डिजिट सिमिलर रिपीट होता है, राइट. We can write here 0.9 bar. Okay, I have taken 5 nines instead of 1 9. Okay, subtracting 1 from 2, 10x equals to 9.999 and x equals to 0.999. We will get here 9 and here 9. So 9x equals to 9, x equals to 9 upon 9, that is 1. What is this? 1. This is not fair because here it is 0.999999 and here I have got 1, right? Why? We have discussed here 0.999999 is very nearer to 1 and therefore when we correct it to the nearest whole number it will give the result 1. When we correct it to the nearest whole number, the nearest whole number to 0.9999 is 1. So we have got this result 1. Question number 5. Friends, here what can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 upon 17? Perform the division to check your answer. Now 1 upon 17, 17 means 16 digits, 1 less than 17, that is 16 digits may be there. The maximum decimal expansion of 1 upon 17 can be of 16 digits. 1 less than 17, that is, let's confirm by dividing it. You should also divide it in your notebook, friends. Look at here, I have divided it 17 by 1 by 17, 1 by 17. So first of all we don't have enough numbers, so I have taken here 0, then 0 point, then again 0 because 10 is less than 17, then again 0, that is 0, 0.0, then I have taken 17 5s are 85, we have 15, we have put 0, 17 8s are 136. Like in this way, if we divide it for many numbers, many times, that means if we divide it continuously for hours together, we will get these 16 digits repeatedly. Here is 1 and the last one remainder is 1, you can see here 1. So again the digits will be repeat, right? So we have this answer. You will do by it yourself by learning table of 17, friends. Table of 17 is necessary. Now question number 6. Look at several examples of rational numbers in the form of p upon q, where p and q integers will no common factors other than 1 and having terminating decimal representation. Can you guess what property q must satisfy? Friends, here examples of rational number p upon q, right? Q must not be 0. Q must not be 0. P and Q integers with no common factors. No common factors means there is no possibility of cutting of P upon Q, P and Q both, other than 1 having terminating decimal expressions, presentations. So Q must satisfy what property? Then Q must satisfy. If if the number is terminating, then if it is terminating decimal, then the prime factorization of Q has only powers of 2. Powers of 2, that means 2 raised to 1, 2 raised to 2, 2 raised to 3, whatever. Or the powers of 5, 5 raised to 1, 5 raised to 2, 5 raised to 3, whatever. Or the power of both 2 raised to something and 5 raised to something multiplied by. Okay? There must not be any other factors than 2 and 5. If there is other factor other than 2 and 5, that means except 1, okay, that means 3, 4, 4 is factor of 2, right? 4 is multiplier of 2, 3, 7 or whatever other, it must not be terminating. If factors of 2 and 5, so if the factors are 2 and 5, then the decimal is terminating. So Q must satisfy the power of 2 or power of 5 or power of both. Question number 7. Write 3 numbers whose decimal expansions are non-terminating, non-recurring. Non-terminating, non-recurring, friends, I have said you that is irrational number, and we have given here 3 examples: 0.10, 110, 1110, 11110, dot dot dot. We can here 0.20, 200, 2000, 2 4 times 0, 2 5 times 0. Okay. Pattern must not be repeated. Pattern must not be repeated. Here look at here. 1 2 1 1 2 1 1 1 2 1 1 1 2 1 1 1 1 1 2. Right? In this way, we can write number of irrational numbers, that means non-terminating, non-recurring decimals. Now question number 8. Question number 8. Find the 3 different irrational numbers between the rational numbers 5 upon 7 and 9 upon 11. 5 upon 7 and 9 upon 11. So friends, what we do? First of all, we should convert it into decimal. This is fraction form and this one is decimal form. 5 upon 7. If we divide by 7, we will get 0.714285714285. Okay? And 9 upon 11, we will get 0.818181818181. So we have to find out the 3 irrational numbers sorry, irrational numbers between 0.71 and 0.81. Remember. Sorry. Now we need to write 3 different irrational numbers. Therefore, write numbers between 0.71 and 0.81. I have written it here 0.720720. It is between 71 and 81. Okay, right? I have increased 1 0. Now 0.7557 75557 7 4 times 57 7 5 times 57, right? 7 8. These all are between, look, 72, 75, 78, all are between 0.71 and 0.81. So these are our irrational numbers, right? And question number 9 and the last of the exercise, classify the following numbers as rational or irrational. Classify, that means differentiate between, we can say separate both, right? classify into rational and irrational numbers. Irrational numbers are 0 root 23. Now friends, remember, if the numbers are prime and they have root, if the numbers are prime and they have root or cube root or fourth root, whatever, then they are irrational numbers. If the numbers are prime, 23 is a prime number, here 23 is prime number, and it has square root, it is an irrational number. 1.10, 100, 1000, the numbers are given here. Okay, rational numbers, here also there is square root, but number is 225. Whose square is this 225? It's the square of 15. So we can write here 15 instead of root 225. So 15 is rational number, right? 15 square means 225. 0.3796, this is terminating decimal, it is also rational number. 7.478478, barabar, this is also rational number because it is terminating decimal. 78, non terminating but recurring decimal, here should be dot 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 dot. Right friends, so we have completed this exercise, why they are terminating and why not. We have seen this exercise fully, and thank you for watching this video. Friends, आप अपने फ्रेंड्स को ये वीडियोस, ये कोर्स सजेस्ट करें ताकि वो लोग भी आपके साथ ज्वाइन हो सके. थैंक यू वेरी मच.